Hey, what is up guys, Omogonix here and welcome back to a brand new tutorial series here on the channel. So in today's tutorial series, I'm going to be showing you guys how to make a basic horror game in Godot. Now this is only going to be part 1, there will be multiple parts in this series, so if you do enjoy be sure to like, comment and subscribe for more. And without further ado, let's get right into it. So as you can see, here I am opened up in the Godot project manager, and I am using Godot version 4.1.1 for this tutorial. I do recommend that you guys use a Godot version 4 for this tutorial, so yeah, any Godot 4 version should be fine. And what we're going to be doing is we're going to be creating a new project. So when you're in your project manager, what you want to do is you want to find the new project button and press that. And then what that will do is that will then bring up the Create New Project window. So as you can see, we can change the project name. So I'm just going to set mine to Horror Game Tutorial. So that's what my project name will be called. And then as you can see here in the project path, this is where our project will be created. Now, if you have red text saying something like, you cannot save a project in the selected path, please make a new folder or choose a new path. What you do here is you can just click Create Folder, and then boom, a new folder will be created for your project, and then the red text should disappear. And then once you have a green arrow next to your project path, that means it's all good to go. And yeah, so then next up we have the renderer options. So we have forward plus, mobile, and compatibility. Now, I will be just reading off the dot points of what the renderer options do. So yeah, so for the forward plus renderer option, it supports desktop platforms only, has advanced 3D graphics available, can scale to large and complex scenes, uses the rendering device backend, and it has slower rendering of simple scenes. So the forward plus renderer option is basically the most advanced renderer in Godot, so if you want to have the best graphics possible in your game, then forward plus is the way to go. However, you do need to have a Vulkan compatible GPU in order to use the forward plus renderer option, since the forward plus renderer uses Vulkan as the primary renderer, so yeah. And then we have the mobile renderer option, so this supports desktop plus mobile platforms. It has less advanced 3D graphics, less scalable for complex scenes, uses the rendering device backend, and has faster rendering of simple scenes. So basically, this is similar to the forward plus renderer option, only it's more for mobile devices and it's less advanced. So I'm pretty sure for this you still do need a Vulkan compatible GPU, however it is less advanced than the forward plus renderer option, so yeah. And then last but not least we have the compatibility rendering option, so this supports desktop, mobile and web platforms, so if you want to make a web game then the compatibility option is the way to go. It has the less advanced 3D graphics available. It's intended for low-end or older devices, so if you have a low-end PC, then this might be the best option for you. It uses OpenGL free backend instead of the Vulkan rendering. It uses OpenGL rendering. And then it has the fastest rendering of simple scenes. So yeah, so if you want the best performance available, and you don't really care about graphics too much, or your PC just can't handle the forward plus or mobile renderer options, then compatibility is the way to go. But for my tutorial, for my project, I'm going to be going for forward plus rendering. But yeah, you guys are free to choose whatever renderer you want, but for this tutorial, I'm going to be going with the forward plus option, so yeah. And anyways, once you're all done, you can now create and edit the project. So let's go. And now finally here we are. So once your project is ready, it will just be created. And that can take a bit of time. And finally here we are. So now here we are in our project. Alrighty, so now that we're in our new project, now let's get to creating a scene so then we can actually get our player to walk around when we eventually make our player controller. So what we're going to do is, so as you can see, when you first launch up a new project, you'll be opened up into an empty scene, and to the left here, you'll see a thing saying create root node. Now what the root node is it's basically like the parent node of our scene, and it's the node in which every single other node will go under. So imagine nodes as like objects in Unity. If you're someone who usually uses Unity a lot, nodes are sort of like objects in Unity, so yeah. So what we're going to be doing is we're going to be creating a 3D scene. And there we go. So now we have a node 3D in our scene, and this is going to be like the parent root object of our scene. So what you can do is you can actually double click it to rename it, and I'm just going to rename my node to level. You guys can name it to whatever you like. And yeah, so obviously we're going to need a surface for our player to walk around on. So we're going to need to get out some kind of flooring, right? Well, here's what we're going to do. So we're going to click this plus icon here to add a child node to the scene, and we're going to search up static body, or just static, and you should be able to get it. And we're going to need a static body 3D. So if you don't know what a static body 3D is, there is a description here which says a 3D physics object, a 3D physics body that can't be moved by external forces. When moved manually, it doesn't affect other bodies in its path. So basically it's a physics body which is static, you know, it doesn't move unless you manually move it, like via an animation or something like that. But so what it means here by when moved manually it doesn't affect other bodies in its path, let me give you an example of this, okay? So in my game Xmas Slaughter, that game is actually available to play on Itchio for free if you want to try it out. In my game Xmas Slaughter, I have platforms which you can jump on. Now, those platforms are physics body 3Ds, I think is the correct node for them. I think that's what it's called, physics body 3D. Let me just look it up. Yeah, wait, no, it's not. Rigid body 3D, that's what it's called. So they are rigid body 3Ds, right? But anyways, when I was first doing the platforms, they were originally static body 3Ds. But I found that when I animated them right, the player, when jumping onto the platforms, wouldn't actually move with the platform. But then when I changed the type to a rigid body 3D, then the player would actually move along with the platform even when they weren't moving. So basically the static body 3D, it's essentially just used for normal floors and walls and stuff like that, you know, just normal object collision, you know, like when the player or another object collides with like a floor or a wall or, you know, just another immovable object, then the static body 3D is what you'll use for that. So let's get out a static body 3D. And so now that we have out our static body 3D, as you can see, there is like a yellow caution sign next to it, and let's read what it says. So it says, this node has no shape, so it can't collide or interact with other objects. So what we need to do is we need to add a collision shape to our static body 3D. Now I'm just going to rename this to floor. You guys can rename it to whatever you like. But yeah, so we're going to be right-clicking on the floor, and then we're going to be going add child node, and we're going to add some collision to this. So we're going to go collision shape 3D, and then once you have your collision shape 3D, you're going to go to where it says shape in the inspector, and you're going to click on empty, and then you're going to select new box shape since, you know, you want to walk around on a floor. So you would either get out a box collider, or let's see what else there is. Actually, yeah, I think that is probably the best one for a floor, is the box collider, the box shape 3D. So consider going with that, and yeah. So that there is our static body 3D kind of setup, but we do need a mesh to render our floor, since as you can see right now, our floor is currently see-through and we can just see the outlines of the collider. So how do we get like a cube, say for example, to represent our floor? Well, what we do is we right-click on our static body 3D node, the floor node, we go add child node, and then we go mesh instance 3D. And this is what's used to render objects in Godot. So in the inspector with your mesh instance 3D selected, you just want to go to where it says mesh, click on empty, and then you guys can either get out a quad mesh if you want that to be a floor, or a plane mesh even, but I'm going to be going with a box mesh. Oh, sorry, I accidentally just got out a capsule. I'm going to be going with a box mesh for this tutorial, so there we go. And now we have a basic cube in our scene. So that there is basically how you set up a cube in Godot. And what we're going to be doing with this now is we're going to be selecting the parent object of the floor, so just the floor itself. And we're going to be going transform, and as you can see here, we can actually scale our cube, rotate it, position it, whatever you like. I mean, you can even just do that with the arrows in the scene and by changing the tools up here and whatnot, right? But yeah, so as you can see here with the scale, this here actually locks the scaling this option here, this little icon here. So when you scale the y-axis, for example, every other axis will be scaled. But if you want to disable that, what you do is you just click on the icon, and then when it shows the keychain thingy looking snapped, then that means that it is no longer locked. So if you just want to scale the y-axis, you can do that without scaling all the other axes as well. So yeah. Anyways, I'm going to now be making a floor. So I'm just going to make this maybe 30 by 30. This is just going to be a test floor. So yeah, we're not going to be like making a horrifying scene in this part of the tutorial. That's going to be saved for another part. Right now we're just making a basic scene for our player to walk on, so yeah. And what we can actually do here as well is, now that we have a floor in our scene, let's add some walls as well to test out some player collision and stuff like that. So what I'm going to do is I'm going to select my floor, and then, oh, I've already had it selected. So I'm just going to select my floor and then press Ctrl D to duplicate it. And this is going to be one of our walls in the scene, so I'm just going to rename this to wall. And then I'm going to scale it to be more like a wall instead of a floor. So if we go to transform, I'm just going to like set the x-axis to 10, the y to 5, and that to 10. And there we go. So we're just going to set up some basic cube looking walls in our scene. And so there's one, and then there is another, and there we go. So I'm just going to add like one more, and there. So that there is going to be our basic scene for this tutorial. And then if you want to save, just press Ctrl S, and then we can actually create a new folder for our scenes, and we can call this scenes. And then I'm just going to call this level. You guys can name your scene whatever you want, but then just save it, and then boom, if you look in your scenes folder in the file system explorer thingy, as you can see, our scene is now saved in our newly created scenes folder. Alright, so next up I'm going to be showing you guys how to set up some basic lighting in your scene. So if you look here, you'll see these two icons, like an earth or a globe looking icon, and then a sun icon. So what these are for is these are used to preview what your scene would look like if it had lighting and an environment, but if you disable it, you can actually see what your current scene lighting and environment would look like, but then if you enable it, then you can actually preview it. But yeah, so in order to add some lighting into our scene, like some actual lighting, what you need to do is you need to go to your level node, or you can just press the plus icon as well. I'm going to right click, go add child node, and we're going to add a directional light into our scene. And there we go, so now our scene has some basic lighting, but you might be thinking, wait, but there's not really much change, and that's because of the direction of the light. So you can actually change the direction of it, I think, by going into the transform and then rotating it. Yeah, there we go. And now, as you can see, the directional light actually has a bit of impact. And we can add shadows as well. You just need to go to the shadow option on the inspector and go enabled on, and there we go, now we have shadows in our scene. And so I'm just going to rotate this, and there we go. So I think that looks good, and there we go, now we have some basic lighting in our scene. And yeah, if you want to rename the directional light, that's totally fine. I'm just going to leave it as is, but yeah. And I'll actually move it to the top of the hierarchy as well, just so that it's easier to find. And make sure you save as well. Press Ctrl S as you continue going on in case your game crashes or whatever, or your engine crashes, I mean. So now with the environment, just click on these three dots here. And as you can see, we now have some preview environment stuff. So if you actually change some of these options, you can actually preview what the environment would look like with these sorts of different options. But yeah, so I'm just going to be setting, oh, I don't think I can set that back to the default. We'll just set it to something like this, you know, so yeah, there we go, that's a sky color. And you can set the ground color, sky energy, and then there's a bit of post-processing as well. So I think this is like ambient occlusion, then we have glowing, and then tone mapping, and then this is like global illumination. But yeah, I remember once enabling that and my whole PC crashed, or my whole engine crashed, I think. I forget either way. But yeah, because my PC isn't really the best, but you know, if you have a good PC, then you can use global illumination. But be careful if your PC's sort of low end like mine, because yeah, then it might cause a bit of issues. But yeah, so to add the environment to your scene, you just go add environment to scene. Oh, click it again, and there we go. So now we have our world environment. And now, as you can see, we can no longer toggle the sun or globe options to preview what it would look like with an environment or a sun, because, well, now we already have it in the scene, so now we can no longer preview it. So with your world environment, there's a bunch of different stuff we can change here, but I'm going to be getting to that in a later part of the series, since this isn't all needed right now, but there is a bunch of stuff to change here, I will tell you guys that. So yeah, it is pretty exciting. And yeah, so there we go. That there is how you set up some lighting in your scene. Alright, so now that we've got our basic scene set up, let's now set up our player. So what we're going to do is, at the top here, as you can see with our scenes, you can actually press the plus icon here to add a new scene. So we're going to add a new scene, and it's going to be a new 3D scene. And what we're going to do is we're going to rename this to player. So this is going to be our player. And then we're going to right click on the parent node here, and we're going to change the type of it, and we're going to type up character body 3D. And so the character body 3D, this is going to be used for our character controllers controlling, so yeah. So now that we have our character body 3D, what we're going to do is we're going to give it some collision. So we're going to right click, go add child node, and then search up collision shape 3D. And then we go shape, empty. And then we click on new capsule 3D, and then now we have a capsule collision for our player. Now you guys are free to use whatever sort of collision you want, whether you want to use cylinder or box, whatever. But I do think that using a capsule shape is probably the best, so yeah. So now that we have our collision shape in the scene, what we're going to be doing is we're going to right click in our player again. We're going to go add child node and then mesh instance 3D. And we're going to add some visuals to our player so then we can actually see our player and its scale and all that sort of stuff. So yeah. So we're going to click on the empty here again, and then we're going to go new capsule mesh, and then this will set up a new capsule in our player. So now we can actually see what our player looks like, and it is a capsule. So now if you actually click on the capsule in the inspector, what you can do here is there's actually a bunch of different properties that you can set. The radial segments, this is actually used to define like how detailed the model is. So if we set this to something like 14, as you can see, it changes its detail a bit. If we set it to something like 4, it is a lot less detailed and it's just not that good quality, so yeah. So the radial segment sort of determines the quality of the shape, so I'm just going to set it to something like 14 looks alright. I think 14 looks pretty good. And then the rings we'll leave at 8, I think that looks alright, so yeah. And there we go. So now we have our capsule all set up. And then we can actually press Ctrl S to then save our player, and you can go into your scenes folder and then just press save to then save your player, and then our player is then saved into the scenes folder. So what we're going to do now is we're now going to add a script to our player. So you want to select your player, then you want to go to where it says script in the inspector, go empty, and then go create new script. Now what's interesting about creating a script on a character body 3D is it will actually give you a character body 3D movement template. So as you can see here, you can actually toggle the template on or off, and it says character body 3D basic movement. And yeah, so we can basically just have, you know, some basic movement already implemented into our scene. And that is really cool about Godot, the fact that it already has like a character body 3D movement script implemented into it by default. Now, this isn't a first person script by any means. We actually need to do the first person movement ourselves, but this does just give you some basic movements, so yeah. And so what we're going to do is we're actually going to create a new folder for this, and we're going to call it the scripts folder. Oh, I'm accidentally creating it in the scenes folder. If you want to go back a folder, you just click on this arrow here, and then that will take you to like a root folder basically. We go create folder. We're just going to create this called scripts, and then we're going to save our script here just called player, and then boom. And now we can save our script if everything here is green. And yeah, so now let's go. And now, as you can see, we now have our basic player script. And this can be used for any purposes, first person, third person, you name it. But with first person, there's a bit of a catch, and that is that it doesn't come with camera rotation. You need to actually do that yourself. And that's why we're going to be creating a camera rotation script. But first, before we do get on with that, I want to explain what each part of this script does so then you guys do understand it for yourselves. So yeah, let's get into explaining. So extends character body 3D, that basically just means that this is a character body 3D script. This is a script that is used for the character body 3D. And then we have our speed variable. Well, this is called a constant. Now, I don't really know too much the difference between like a constant and a variable. I'll have to look a bit more into that. But yeah, I can probably show you a thing here on the screen right now, just showing what a constant is compared to a variable. So yeah. But yeah, I think with a constant, it can't be changed at all, because with variables, they can be changed during a scene. So if you want to change the speed of your character during your game, right, you can do that. But if you are using a constant, I'm pretty sure you can't do that. And yeah, and how I know that is because I've tried to do that before, but in games where I want to change the player's speed, I always change the constant to just a var, a variable. So if you want to do that, then yeah, you can. But yeah, so basically constants can't be changed during runtime of your game, but variables can. So if you want to use variables instead of constants, you can change over to variables instead of constants. But yeah, but for now, I'm just going to be using constants. We might be changing to variables later on in a later part, but for now, it's just going to be kept to this, since there is no reason for us to change anything right now. And then we have our gravity, so we have a gravity variable, which then equals to what the setting of the default gravity equals to in our project settings. So if we go into our project settings and you search up gravity, I think it's here. Yeah, so the default gravity value is 9.8, but if you want to change this, you totally can. And then the gravity of our player will be changed based on what the project settings of the default gravity is set to, so yeah. And then we have our physics process function, so this function is used specifically for physics purposes. So if our player is not on the floor, then its y velocity will go down. So depending on what our gravity equals to, our velocity of our character will go down depending on our gravity, then multiplied by delta, which then will basically make our speed of the player falling time dependent instead of frame rate dependent. Because if it's frame rate dependent, then that would be a bit broken. So yeah. And then we have the jump input here, so if the player presses the UI accept input, we will be changing this later on. I will be teaching you guys about the input system later on, and the player is on the floor, then the player's y velocity will equal to the jump velocity. So the jump velocity is 4.5, so the player will go up based on the jump velocity. And then we have, the input direction, so we have a variable created here called the input direction, and this will basically just be getting the input direction of our player's input based on the inputs we have, so UI left, UI right, UI up, and UI down. I'm pretty sure these are the different arrow keys, but we will be changing these later on in the tutorial, so I will be getting to that. And then we have the direction, so this will be the direction our player moves in, so yeah. And then if our player is moving, so if direction is equal to true, so if our player is moving, then the player's x and y velocity values will then equal to direction times by the speed, so they'll be multiplied by the speed. Else, if the player isn't moving and direction equals to false, then it will just move towards the velocity value and then it will stop, basically. So yeah, it will no longer move. The player will just stop. And then move and slide, this will basically make our player move. So yeah, and that is the player script explained. So hopefully I explained that well for you guys. And yeah, now let's actually continue on with this tutorial. So what we're going to be doing now is we're going to be creating our camera. So for our player's camera, first off, what we're going to do is we're going to be going player. So we're going to right click on the player, go add child node, and then we're going to search up camera 3D. And then this will add our a camera to our scene. So now let's position this camera to, you know, just a certain position, like the head of our player. And there we go, I think that is a good position for our camera. And also make sure that the camera is facing in this particular direction here, facing the blue line. So if you actually look up here, you can actually see like the direction of which I am facing. So the camera is currently facing the opposite of the Z direction, and this is actually forward. So we want to make sure that our player is facing in this direction specifically, opposite of the Z axis, because, you know, that is forward in Godot. And yeah, I used to always think that, you know, facing towards the Z was forward, but it isn't. It is actually facing opposite of the Z. So yeah, that is forward in Godot. And now with our camera 3D, we're actually going to right click on this, and then we're going to go down to reparent to new node. So we're going to be giving it a parent object, and it's just going to be a standard node 3D. And I'm going to call this head. So this is going to be the head of our player, or the head of our camera. Now, wait, something that I just noticed is it's not really positioned right. Here, wait. So, when you add the head to your camera 3D, something which I just noticed is it adds it into the middle of the scene. So, you know, it just zeroes it out, basically at the middle of the scene. But the problem with that is now our camera isn't positioned right with the parent object. So what you want to do is, if this happens to you, you want to drag out your camera 3D from underneath the head, and then you want to make the head a child object of the camera 3D, and then you want to zero out the position of your camera 3D, so I mean of your head, sorry. So we're just going to set the y-axis to 0, and now it is positioned perfectly with where our camera is positioned. And then if we make the camera 3D a child object of the head again, and then boom, it should all be fine. So yeah, that there is how we set up the player's camera in our scene. But now what about the script? Well, let's get to that, guys. So what we're going to do is we're just going to save there, and then we're going to go click on script. So make sure that you have your head selected. You want to make sure that you have your head node selected. Then you want to go click on script empty, new script. And then for this, I'm just going to be calling the script camera, and we're going to be saving it in the scripts folder. And unfortunately, there is no template for a camera like movement script at all. So there's no camera rotation script, unfortunately. That would be nice if there was a template for that, but there isn't. But so here's what we're going to do. We're going to create a script. And there we go. So now let's get started with this. Alright, so to start off for this script, what we're going to do is we're going to get rid of the starter stuff here, and we're going to enter out a new variable. So it will be called var sense, and this is short for sensitivity. And I'm going to make this equal to 0.005. Now you guys are free to set this to whatever you want to, but I'm just going to set it to 0.005, and there is a reason as to why it needs to be set to so low. And by the time I actually, you know, show you guys how to do this camera script, if you want to try setting it to a much higher value and seeing what I mean, then yeah, you guys will get what I mean as to why we need to set this to such a low value. But yeah. So what we're going to be doing to start off here is we're going to be doing a ready function. So we're going to go func_ready. So what ready is for is this is for like at the start of our scene. So when our game starts, then the ready function will do its thing automatically. So yeah. So what we're going to be doing now is we're just going to go indent, and then we are now going to type in the following: input.set mouse mode, and then we're going to then enter input.mouse mode captured. So what this is going to do is this is going to set our mouse mode, like our cursor, you know, my cursor that you can see moving around right now, to the captured mode. And what that does is it locks our cursor to the middle of the screen, and it makes it invisible, so then our cursor isn't moving around and stuff as we're playing our game. So then it's just locked to the middle of our screen, and as we're rotating our player around, our cursor isn't moving around at all and hitting the edges of screens and stuff like that. So yeah. So that's what setting our mouse mode to input.mousemode_captured does. Alrighty, so what we're going to do now that we have our ready function ready, is we're going to go down the line and then indent back to here, and then go down another line, and then we're going to write func underscore input, and then we're going to do parentheses, and then event, and then the 2 dots, and then input event. And then after that, we're then going to then go hyphen or dash, whatever that's called, and then arrow, and then void. Oops, sorry, void. And then you just want to do the 2 dots again, and then you just want to then indent. And then you want to write if event is input event mouse motion. So basically, if our mouse is moving, then we do the 2 dots. Get underscore parent. So what get parent does is this actually gets our player object, since the player object is the parent object of our head. So we're going to do get parent dot, and then rotate underscore y, and then in parentheses we're going to do minus event dot relative dot dot x, and then we're going to multiply that by our sensitivity. And yeah, so that there is us rotating our player on its y-axis, so you know that just means rotating left and right based on the left and right movements of our mouse, so yeah. And then we're going to go down a line, and for this one we're just going to go rotate underscore x, and then in parentheses we're going to go event dot relative, well minus event dot relative dot y multiplied by sense. And so what this is going to do is this is going to rotate our actual head itself on the x-axis. So when we move our mouse up and down, that will then rotate our head up and down. So our player will rotate left and right, and the head will actually rotate up and down. That is how it is going to work with this. And now, last but not least, we need to actually clamp our camera's rotation. So we're going to go rotation.x equals clamp, and then in parentheses, rotation.x, and then a comma, and then deg underscore to rad. And if you're wondering what this does, deg underscore to rad, it basically changes, it basically converts the degrees to radius, or radians, or something like that, whatever it's called. I forget what the actual term is. I've looked it up in the Godot documentation before, but yeah, it's like degrees to radius or something like that, I'm pretty sure. You guys, I'll probably show a thing here on the screen if I'm, you know, a bit confused on that, but yeah. So you want to do degrees to radius, or just deg to rad for short. And then in here, you just want to write -90, or whatever value you want. So whatever you want to clamp your camera's rotation to, then that is, you know, totally fine. You can set the value to whatever you like, but I'm going to be setting it to -90. And then what we're going to be doing is we're then going to be doing another comma, and then we're going to basically just be copying and pasting this, and we're going to set this to 90. So this will be our minimum clamp, and this is our maximum clamp. So yeah. So the minimum clamp I have set is -90, and then the maximum clamp is 90. So this will basically allow our player to look fully up and down, but not look in a 360-degree rotation, so yeah. And yeah, so that there is how we do our camera script. It is pretty basic. So anyways, once you're done with your script, you just want to press Ctrl+S to save it, and there we go. And now our camera should actually be ready, like our player should actually be ready to be used. So what we're going to do is we're going to go into our level scene, so we're going to switch back to our level scene. And then from our scenes folder, I'm actually going to then drag in our player, and now we have our player in our scene. Alright, so with our player now in the scene, let's now position it. So then it is in a good position, and there we go. There is our player, and boom, we now have our player in the scene. Now, before we do use our player, there is one last thing that we need to do, and that is setting up the input system. So I'm just going to save the scene. And yeah, so now we're going to be setting up the input system. So I'm going to be going project settings, and then input map. And here is where we can set our inputs. So I'm going to be setting a new input called forward, backward, left, right, and then last but not least, jump. So here are our 5 inputs that we're going to be doing for this tutorial. So you want to click on the plus icon on each input basically. So on forward, for example, click the plus icon. And if you press a certain key on your keyboard, like the W key, for example, now I'm going to press the W key because in order to move forward in most games, you usually press the W key. So yeah. So we have the W key, which will be set for our forward input. And by the way, you can set controller inputs if you want to as well. So if you want to set controller inputs, that's totally fine. You can do that. So yeah. But what we're going to be doing now is we're going to be setting the backward input to S, and then the left input to A, right input to D, and then last but not least, the jump input to space. And there we go. So now we have all our 5 main inputs set for this character controller. And now we can save, and if we go into our player script, we can actually then change these input names here. So UI accept can be changed to jump, or whatever the name of your jump input is. UI left can be changed to left. UI right can now just be right. UI up is now forward. And UI down is now backward. And there we go. Now our player is fully set up. So now what we can actually do is if you actually click on your scene in your scenes folder, like your actual main level, and you right click on it, you can actually set that as your main scene. So if you ever click the play icon in your project and you want to test out your game, then it will just load up into your main scene automatically. But yeah. So what we're going to do is we're going to press the play button and we're going to test out and see if this all works. And boom, as you can see, I can now freely move around and jump around, and yeah, everything is working perfectly. So if you guys did enjoy this tutorial or you did learn something from it, be sure to like, comment and subscribe for more. In part 2, we'll be doing a bunch more stuff. I haven't thought of what we'll be doing for part 2 yet, but I will be planning it, so yeah. But overall, what we've done in this tutorial is I've showed you guys how to set up a Godot project. I've showed you guys how to set up a basic scene, how to set up some basic lighting, how to set up a basic first-person player controller, and I think that is quite a big achievement for this part, so yeah. Anyways, again guys, if you did enjoy it, be sure to like, comment and subscribe for more tutorials like this in the future, and I'll see you all next time. Bye-bye.